So I'm probably talking to the choir because you all seem to be getting your work done when I ask you to and when I've assigned it. So that's really good. Okay. But here we just filled this out, and I know on the video, you might need to stop it for you guys just watching the video because I already went over it with the group in this group that's here today. So I don't want to go over it too long, but basically fill this out. The reactants are before the change and products are after the change. We're going to have an arrow in between, and we're going to have all these formulas. Okay. So we're going to have chemical formulas. We're going to have chemical formulas that are at the beginning. They're going to be on the left side. They're going to be on the left side of the arrow, and they're going to be reactants, okay? And then we're going to have chemical formulas that are going to be on the right, that are on the right side. That's going to be your products. And we're going to be, most of the time, you guys are going to have the formulas given to you, and you're going to see these states of an aqueous solution. You could have a liquid, usually water. Most of the time it's going to be water, H2O. And then you're going to have solids and sometimes gases. And a lot of times when you see a gas forming, a new solid forming, sometimes we'll have acids and bases that make water. There's going to be actual signs of chemical changes, okay? And the one thing about solids I want to write down is another name for that. If it's a new solid being formed, a new solid product, is called a precipitate. Not the word you might use for like precipitate. You might think of rain being a precipitate. Well, in many ways, it's water forming off the little dust particles up in the sky, but it's the same word, but a different definition. So if we get a new solid product forming, we're going to call that a precipitate. And we're going to use that in the actual lab next week. Okay. Now we're going to equal out the number of atoms by placing numbers in front of each chemical. Now, if you don't have a number in front, then you're going to just have the number 1. But if you're going to double it or triple it or having multiples of each chemical, we're going to put a number in front. We're going to call that a coefficient. So that's going to be what we're doing a lot of this unit. Plus, we're going to talk about the types. Okay. So you guys want to have this little paper. Did you guys get this little paper? We're going to learn the types, understanding that these things on the left are reactants forming one product, or we have reacting with oxygen, or we make one reactant forming many products, or we have a combination of compounds and so forth. And these are the general patterns. We're going to do that on Thursday. We're going to learn about these types on Thursday. So I will have digital copies of this paper, and I'll have digital copies of the packet in case you didn't get them. I thought for the most part, you guys that are in the class right now, you definitely have these papers, but we're going to be using this especially on Thursday. Okay. Now, if you go to the other side, the bottom part of the page, we're looking at this part being the reactants. So we mark it as reactants, and you have hydrogen and oxygen reacting to form water. And we've actually seen this when we did the potassium in water. This is when we saw the fire. So hydrogen can react with oxygen really slowly if forced to do it slowly, but a lot of times it makes a fire because it's burning. It can be explosive. It's what drives the actual space shuttle up into the sky. If you do a certain amounts of hydrogen, oxygen as fuel, you can make a space shuttle or a rocket go up in the air. Now, a lot of times they use other types of fuels, but you could base it on a hydrogen oxygen type reaction. Now, when you talk about individual particles, especially covalent compounds, we're going to call them a molecule. So we're going to say 2 molecules of hydrogen and 1 molecule of oxygen. Now, we don't have the number in front, but we could put the number 1 in front. We don't have to, but there is at least one molecule of oxygen, and they rearrange to form two molecules of water. So these numbers in front are called the coefficient. We have little letters afterwards. That's the state of matter. These are both gases combining together to form liquid water. If it's under enough like fiery conditions, you actually can make a gaseous water too. But when you're on the left side, we're going to call them reactants. And when we're on the right side, we're going to call them a product. Okay. Now notice we have the 2 here and the 2 here. And if you look at it originally like this to try to balance it, is we could do hydrogen. And we're going to do this a little bit on our future practice problems to try to balance. So we're going to write out 2 hydrogens. We're going to remember that hydrogen, different elements are diatomic. So I'm going to put down diatomic elements. Remember, we talked about that earlier in the year, but we're going to have hydrogen and oxygen and fluorine and bromine and iodine and nitrogen and chlorine. And we actually can write it out like this term called Brinkel, B-R-I-N-C-L. That's for those 4 symbols. And then we have Brinkel-Hoff. And so that little phrase is how we remember. So whenever we talk about an element hydrogen or element oxygen, they're naturally covalently bonding. All of these are covalently bonding and sharing their electrons, and they don't want to be alone. In the world, they're more stable together. So we're going to put hydrogen as a 2 and oxygen, and there's 2 of them. So we have 2 of them here, 2 of them here. But on the other side, we just have HOH like this. And I kind of write them out like formulas. So what we're going to do is another way to kind of balance it, and we're actually going to do this on the next side, is we have 2 oxygens on this side, but only 1 on this side. We have 2 hydrogens on this side and 2 on the other side. And you'll notice that these are not equal. These are not equal, but these are. But we got to figure out how to make everybody equal, okay? So that's what we're doing. Let's actually do it on this next page, okay? So we're going to go to the next page. I actually have this as an example, okay? So again, we're going to take hydrogen, and there's 2 of them. And if you want to even just write down the number 2, you could visualize it and put 2 hydrogens like this and 2 oxygens, and then do HHO. If you want to write them out like that, you could physically see that these are equal. These are equal, but these are not. These are not. And you actually can make it even easier to make it really visual, is you put a line down the middle like I was doing here. This is my copy from last year when I did it with the students. And I just took a copy of the program, the notebook on the smartboard, but I can't use both of the devices with the microphones. So we're going to put a line down here. We're going to compare them. So we have hydrogen and hydrogen. We're going to do the hydrogen first. We can put it over here on this side. We could put oxygen on this second because that's the 2 elements. Here we have 2 hydrogens, and here we have 2 hydrogens. They're equal. Okay, so that's good. Hydrogen equaling both sides. And then we have 2 oxygens on this side, but only 1 on this side. Okay, now that's a problem. That's not good. That's not good. Okay, so I'm doing my thumbs down here. Okay, that's a thumbs down. Okay, so that means that we got to equal it out. Now we can't change any little numbers. The subscripts cannot be changed. Okay, the little numbers cannot be changed, and those little numbers cannot be changed, and that's called subscripts. When we write out the formulas, or the formulas are already written there for you, the little numbers cannot be changed. You can only add in big numbers. Add in big numbers in front. Okay? Big numbers in front. And they're called coefficients. Coefficients. Okay? So we got small numbers, that's subscripts. Big numbers are going to be called coefficients. Okay. So what we're doing is we got to equal out the oxygen. There's only one here. So what we have to do is we have to put a number 2 in front. We want to double that. We want to make 2 of them. So what I'm going to do, and there's like a little, you're going to be changing things around and erasing it. So when you do these samples, you want to definitely do them with a pencil. So we have 2 here, and actually to make it easier, I do need to make 2 of them. So I'm going to physically make this so you visually see them all. And now you see that there's 4 H's. We just changed H's. And let me go ahead and move these down here. There's 4 H's, okay? And now we have 2 O's. So the O's are good, but that kind of made the H's all messed up. But what we can do is now we have 4. We can now make 2 of these and put a 2 in front of here, and that makes a total of 4. And now this changes to a 4, like this. Now, I know it seems kind of like frustrating that you have to change things. That's why you want to use a pencil, okay? And you want to try to use visuals to help you understand. But because you have to double this, you have to double the hydrogen molecules, you're going to have just 1 oxygens, and you're going to have 2 of the waters, and that distributes out here so that you have 4 H's and 2 O's. You have 4 H's and 2 O's. It's another way of doing it. You could just put the numbers below each one, and then you're going to change numbers a lot to equal things out. So I know it can be a little frustrating. Now, in your actual paper, you have another example that I did not have on my paper here, and that is going to be here. Let me write it out for you. We'll do that example. And I had a purple marker. Just a second. I'm trying to find my purple marker here. Okay. So our next example is this methane and oxygen makes CO2 and water. And these guys are reacting. These guys are being produced. And we want to equal out the carbons, equal out the hydrogens, and equal out the oxygens. And this oxygen is only here, but it breaks in part into CO2 and water. Okay, so let me show you that. Let me write it out here. Again, any questions, anything at all, let me know here. Anything at all I could help. These are called the what? What do we call these guys on the left? It starts with an R. What do we call these things on the left? Anybody want to write it out on the chat box? And then what do we call these things on the right? These are called, they're reacting, so what are they called? It starts with the letter R. Yeah, that's right. Good. And then over here, they're being produced, so they're what? And Abigail got it, girl. AJ did, and that's products. These are reactants, rearranging. So we're going to use the word rearranging to form products, okay? So they're rearranging. The actual atoms aren't changing. They're just rearranging. But what we're going to do is we're going to look down here and try to talk about balancing. So I'm going to put a line here. We've got some C's, H's, and O's on the left, and we have to have the C's, H's, and O's on the right. So we're going to put C, H, and O on the right. And as you look across from left to right, this has just nothing between the C and the H. That is implying a 1. So we have 1 C. Over here, we have 1 C. There's nothing between the C and the big O. So there's no number there, but you imply it being 1. You don't have to have the 1 there, but you want to make sure you know if there's nothing between the capitalized C and the capitalized H, there's 1. So that's really good. That is good and equal, okay? Then we have 4 H's with a little tiny 4. Again, that's called the what? What do we call the little numbers? The little numbers are called what? What do we call the little numbers? And then we're going to be adding in big numbers. That's right, AJ. These are called subscripts, okay? We're going to use this a lot today and tomorrow for the entire unit, okay? The entire unit we're doing. And then the big numbers, when we put big numbers in front, it's the word we have from like algebra class. What do we call the big numbers? It starts with a C. I know yeah. Thank you, Rod. Thank you. Thank you, Gazelle. Good. They're called coefficients. Good. You guys are learning just fine. Great job. Great job. Okay. So that's what's going on. Now I'm going to erase those words because we got to move on to actually balancing this. Okay. We're going to use the little numbers to kind of tally up what we have. So we have 4 H's on the left. And as you look over here, we only have the 2 over here. You can even visually write them out like COO if that helps you out. I'd recommend visualizing it like this, HHO. So you can visually see, you can do it this way just to kind of see them. You can put C and 4 H's. I recommend it. You don't have to, but if it visualizes, hey, you got more H's on the left and not enough on the right, that means you're not equal. And then you have 2 O's. So it's really helpful if you want to do this extra step. I will do it, try to show it that way in the class, you know, tomorrow's lesson and whatnot. Okay. So we have, I'm sorry for the glare from the classroom. I probably should do this with the light not on, but we have 1 C and we have 1 C here. Okay. And then we have 4 H's, but over here we only have 2. Now you cannot change the little numbers. You can't change the little numbers. You can only put big numbers in front. Okay. You can only put big numbers in front. So we have to make more H's and we have to make a multiple and go ahead and make this a 2. And then go ahead and make another visual particle with 4 H's now. Do you see how we have 4 H's? So now this is good. And we're going to change that to a 4. So our C's are good. Our H's are good. Let's check on our O's. Our O's have 2. But here we have 2 here and we have 2 more over here. So right now we have 4 O's, but over here we only have 2. Okay. And ultimately, if we change any of these other numbers, we're going to affect C's and H's. So what will happen a lot of times, guys, is when you do the O last, you're literally are going to do in these special type of reactions, we're going to call these combustion reactions. We're always going to balance the C's first. We're going to balance the H's second, and we're going to leave the O's for last, okay? And we're always going to put the number up here with O2. Again, this side has 4 O's. This side has only 2. So what would I put up here? What would I put in front of the O2 to get it to the right number? Anybody want to help me out there? That's a right, Giselle. You put a 2 in front, and now that makes 2 of them, and that changes it to a 4, and now everybody's equal. So we're going to have 1 of these. Now, you don't have to put the 1 there, but you can. 1 of these with 2 of these to make 1 of these and 2 of these. So 1 and 2 makes 1 and 2, but they're different particles, different molecules and whatnot. But the number of atoms are the same. And we're going to practice more of that tomorrow. Okay, we're going to practice more of that tomorrow. Okay, but first, let me do one more page, this bottom part, okay? And I need to flip this around, I think, let me just write it out this way. Actually, no, let's write it out here. Okay, so if I can cheat this. So let's do a word equation. Now, again, most of the time, you guys will not have the word equation, but I will like to do it for you guys to recognize what state they are, to recognize what is the reacting, what is producing, and in the meantime, hopefully write out formulas. But I know the formula writing is kind of weak for many of you guys, but we're definitely going to have a solid mercury 2 oxide, and it's decomposing. That's your verb. So I'm going to put a V in front of it. That means you're going to put the arrow here, okay? It's going to decompose to produce. That's actually verbalizing the sentence. And then you're going to make liquid mercury. And then you're going to have an and, which means you're going to put a plus in between and have gaseous oxygen. Now, remember our 7 diatomics. We have bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. So whenever we have oxygen, we're going to make him a little 2, okay? So we're going to put mercury, and that's Hg. You may need your periodic table. Again, most of your equations are going to be written out, but I'm going to try to challenge you to say, hey, this is our reactant. This is our reactant producing our products. Okay, so I want to really recognize that. And I'm going to have some exit ticket questions going over these two, today, later today. I'll send out a remind when they're ready. Okay, so we're going to have a simple set of questions today to kind of go over this lesson, but kind of confirming that you learned it today. But we're going to put a little S. Oh, actually, we're not ready yet because it's mercury oxide. So we're going to have mercury with +2, oxygen with -2. So we have one of each. We don't have to put the formulas, the charges down, but I'm going to go ahead and write it down as HGO, and it's a solid. It is a reactant breaking down. So we put the arrow here because this is the verb. Okay, and it's making liquid mercury alone. So we're going to put a little L there. That's my L, because sometimes when it's just a stick, you might think it's a 1. Okay, and then it makes oxygen gas like that. And we're going to put O2 down. Okay, we have another equation. It says solid zinc is added to an aqueous solution of hydrogen chloride. And then we have a producing part. That's the equation arrow. So we have a reaction. We have 2 compounds over here. And then we have hydrogen bubbling out of solution and zinc chloride remains and dissolved in water. So we're going to have 2 products on the end. Now this is kind of intense to write all these formulas out, but I at least want to ask a question. What is my reactants? What are my products? And you're going to see those kind of multiple choice questions from it. Again, I'm going to use these 2 sentences on your exit ticket questions today. Okay. So we have zinc by itself, solid, reacting with hydrogen and chloride, and hydrogen is plus, chlorine's minus, and you're going to have it aqueous because it is in water. So we're going to do S for solid, solution containing dissolved hydrogen chloride as aqueous. Okay. And then we're going to make hydrogen. And remember, hydrogen up here is diatomic. So we're going to have hydrogen gas. So we have to have a little 2 there. Let me write it out better. Okay. Hydrogen 2. Okay. And then we're going to have now zinc chloride. And zinc is always +2, so we're going to have 2 chlorines. Now, I'm always going to help you with the formulas. You guys are always going to have, you're going to have the actual formulas written out. We're focusing more on the balancing part, okay? But it's going to be aqueous, okay? So that is the 2 equations. We're going to note that mercury oxide is a reactant forming 2 products, okay? So if I ask the question here, okay, if I looked at the first equation, mercury is a reactant or a product. And the first equation here, is mercury a reactant or a product? Can you guys give me an answer in your chat? Is mercury, just mercury, a reactant or a product? Mercury itself. Okay, if I said mercury oxide, AJ, that would be a reactant. But when we just say mercury, if I just say Hg, if I, let's use this here. If I just do Hg, just Hg, yeah, it's a product, okay? If I said mercury oxide is a what? Mercury oxide in that first equation, what is this? That's a reactant, right? So it depends on what I'm saying, what the question, and it's all going to be formula wise. I'm going to either use words and formulas with you guys all the time. I know some of you guys have the formulas down, some of you don't. So I'm really going to show that, okay? So we could balance some more, but I'm going to, work on that tomorrow. I really want to show you a visual with my mercury oxygen experiment, okay? So let me show you that, and then maybe we could balance that equation too. We got like another 9 minutes. This is not from your handout. This is just totally a visual, a video to show you some examples, okay? Now, what we're doing tomorrow, guys, come into class, and we're going to be working here and we're going to this website. It's called Balancing Chemical Game in Schoology. And after we get done here, I'm going to go to the actual web pages in Schoology to show you that. Now, basically it is going to be for 10 points what we're doing, but it's going to be go with your balancing quiz score. So you're trying to earn points in here for the actual game part, but we're going to be getting some lab points. So it's going to be for a lab grade, okay, for tomorrow. So you definitely want to be in here and participating and going online and doing it, but we'll go through it. And it's going to be in the unit of chemical reactions. It's going to be called the Balancing Equations Online Game. And then we're going to walk through it together. But I just want to let you know that page. And eventually you're going to turn this in. You are going to turn this in, but you're going to wait till you get back. Okay, you're going to turn this paper, physical paper in. And then you guys are going to possibly write some things out on the back as well. Okay, then we're going to be trying to balance. And you guys could actually start balancing maybe the simple ones like number 1 and number 3. You can even do number 5 because we already did number 5 in the notes. But you want to, if you want, get other paper. Okay, get other paper so you could visualize it more. I know I gave you some width between them, but it may not be enough. So feel like if you need other paper, you can. This is something you can start working on. We're going to reinforce it tomorrow. It won't be like due right away, but you definitely want to practice on this side. And then later after Thursday, and even before Thursday, you could balance these. Now on this side, this guy is extra effort. So this guy is totally extra. Don't worry about this middle one. If you want a challenge, I would recommend it, but it's totally optional. And even number 3 is a little challenging, and definitely number 3 is challenging and so forth. But we're going to work through this a lot this week to learn. Eventually by the week of the 8th towards like the 11th or 12th of March, we're going to have an in-class test. Okay, an in-class test on balancing. So your goal is to learn about what all the terms mean. Oh, go ahead. I'm sorry, AJ. I'm sorry. I didn't see your question. Okay, hold on. I just had this here. Here we go. Let me get some white paper. So your 7 diatomics are right here. We're going to call this Brinkle, like that's a CL, right? Brinkelhoff. Yeah, that's right, Giselle. That's right. You typed it in just right, Giselle. Good job, girl. Awesome. Brinkelhoff. So when we see bromine being formed or iodine being formed or nitrogen, chlorine, all of these guys are automatically covalently bonding with each other. They're already wanting to share with one another. They don't live alone. They've got to partner up, okay? Does that make any sense? There. Any other questions? I do want to show you a visual reaction. I tried to show you this. We're going to do magnesium reacting with oxygen to make magnesium oxide. Let me show you that visually because yeah, good. Thanks, AJ. Good. So let me show you this before we leave, before you head out for next class. Here, I have this video, and it's what happens is it goes over the bonding part, which is important to go over again, but I want to skip over it to minute 4. So I'm going to try to move this over to minute 4, and I'm hoping it transitions. What happened last period, it jammed. It jammed on me. So I'm going to hopefully get to minute 4 here. Hopefully it's going to start. The bell's rang, but here, let's see. Hopefully, might jam, and I don't want it to. Come on. It did this last period when I tried to move it up. So I don't know. I really don't want to show you the beginning part. Maybe I'll just start it from the beginning. Yeah.
Hi, chemistry kids.
Let me
wanted to do this demo. Hoping to show it to you live, but thought I would explain a little bit better. But
let me see if I can get it.
Yes.
Yeah, good. I think having it going helps. So let's do it this way.
Magnets. They're still atoms and ions.
It's talking about the bonding.
Connected. And that bond
You see how
That
it's
bond is
bonding
really strong.
plus
That
2
bond
minus
is really
2.
strong. Okay.
Now the bonding part's important still. Okay, but the actual reaction is what I want to show you. So here I'm showing magnesium. See how it's a solid gray stuff, okay?
That's what makes it shiny. So metals are shiny, malleable, bendable, moldable. They conduct electricity. But this is it. It's about 0.23 grams. I'm trying to show you that the compound should be heavier, but because of the materials and the lab setup, I can't prove it to you with the mass. But anyways, I did mass it, and then I'm going to put it in the flame. This is the really cool part. See, magnesium reacts with oxygen from the air and makes magnesium oxide. Okay, so let's actually see it happen. Okay?
Oh, come on.
Physically see it. So watch the flame. I'm going to put it in the flame.
Why did it do that?
Collect the product.
Sorry, here we go. Here we go. Sorry, I was making it bigger for you guys. So watch this. And
now it's really bright. So when you see the bright light, you probably want to turn your head because it's really bright. Okay, so when I do that, I'm going to turn my head.
So it's reacting with oxygen in the air and makes that bright light.
Don't look at the video, the light, guys, but it's really bright. And then I'm going to let it drop. It's really bright and it's burning. You guys can see it burning. But that powder, this white powder now, see how white it is compared to the original? This is the original. This is the original metal. It's gray. And then the white oxide is a powdery, but when I tap it on the glass, it becomes this powder. You see how it becomes a powder here? And not all of it.
So I was trying to show you magnesium and oxygen burning together, and in the actual like equation, then we can actually show how you equal it out. See, there's one of these and one of these and one of these to start with, okay? But when you look at it, there's 2 oxygens, but only one on this side. So how am I going to fix it? If you guys help me out, I got to put some 2s in, right? So where would I put my 2s at? Because I've got 2 oxygens over here, but I only have 1 over here. So what did I change this number to? I've got 1 of them at the moment, but I'm going to change it to a 2. And then it makes 2 magnesiums and 2 oxygens. But now that makes more magnesiums, right? So over here, I got to change this one to also the number 2. And then I have 2 magnesium atoms with 1 molecule of oxygen. We're going to call covalent structures molecules. We call these guys atoms with a molecule of oxygen making 2 compounds, 2 formulas of magnesium oxide. But see what now is that they equal. Magnesiums, you have to have 2 atoms and a molecule of O2 combined together in the bright light. Did you guys see that bright light, right? Really bright. And that is that bright light making magnesium oxide. This was gray and this was white. So there's some signs of a chemical change. And when we do the lab next week, and as we talk about, actually seeing reactions, when you see the changes, then you have a chemical change. And these are reacting to form the product. Okay. So we're going to start balancing. Again, you guys could practice tonight and work on, you could work on the next page here, work on this page and do a couple, maybe this number 1, even doing number 3. You can actually repeat number 5 because we already did it. Even number 6 if you want. Some of them are kind of harder than others. Okay. So we need to stop. I know I went right to 10:30. So I hope you guys have a good day and we'll see you tomorrow. Okay. I didn't get a chance to go over the assignment, but definitely, or the things in Schoology, but I did make a new folder and it's going really slow. If you want to stay on, I've got this new folder here. Okay. And I did highlight making sure that you go back and get everything done. But most of you guys already have your stuff done. But I actually have inside the new folder, I have this balancing game. Okay. And we're also have the chapter 9, which is like pages. I'd read the first 5 to 6 pages inside here, looking it over in the pictures. And I did put in the notes today that I went over I did put them in here. So if you do want to, if you didn't get anything copied down, you could actually look at this page and write down what we wrote. Okay. I know that the other reaction of the methane reaction, the CH4 reaction wasn't on here, but everything else is. And I even got them balanced too. Okay. So I'm hoping that all helps. If you need to head out, feel free. It's so good to see you, Justin and Kiana, Giselle, Gabby, Abby, Abigail. Yes, that's right. Go ahead, Justin. We'll see you. Have a great day. And I got this recorded if you need to look back at it. We'll see you later.
So I had two questions. Well,
Sure,
one
yeah.
is just on Thursday morning. That's when I'm leaving for Florida, so
Right.
I'll only be able to attend class tomorrow.
Yeah.
And also, while we were doing the lesson, I did a few of the bondings. I did the one that you listed.
You want to show me, or what do you got?
Yeah, the one that you did for extra effort. I was wondering if I could check it now.
Sure, yeah. Was it, did you happen to get like 4 beginning compounds?
I got 4, 27, 20, and 18.
Right on, Abby.
Okay.
It was perfect. You already know all this already.
Yeah.
You already know all this, but the types, what you're doing for the last thing, sorry, I just took a bite of donut, sorry.
It's okay.
So this last page is what we're doing on Thursday. And my initial intent, this is the copy for the in-class copy, okay? But we can't quite do it the way I'm saying it on here, and I didn't have time to change the directions. So you're actually going to cut up the last page, cut these all up into strips, cut them all up into strips, and you're trying to group them to the types. Like here, we have a magnesium reacting with a compound. Further down, we have other metals reacting with a compound. Or we have other non-metals. Like and what it is you're seeing these patterns. You're trying to match them up to these patterns right here. Now, normally in the classroom, I don't even show this paper until we get done because of like, I want you to discover, hey, you know, there are 2 compounds here and they're just rearranging to make 2 new compounds. And that's the same thing going on at number 3. It's really 2 compounds swapping. It's like a double date and they swapping partners in a dance. You know how you do the square dance?
Yeah.
I don't even know if you guys square dance anymore in PE class or whatever, but you trade places. Now there are other reactions where you have 2 things and 2 things, but this is involving an element in a compound.
Yeah.
Which is a different one. So we have all these different patterns. So when you cut them up, you're trying to match them up with, hey, this one is forming one product, number 2. It's like this first example, which is called synthesis. Okay. And then we have another type when it's always reacting with oxygen, and that's called combustion. Anytime we react with oxygen, anytime we're reacting with oxygen, whether it's a metal, a non-metal, or a compound, anytime it's usually making an oxide of the metal or an oxide of the non-metal, like one compound, but it also makes CO2 and water.
Oh, so the extra effort one would be considered combustion?
Right. And what it is I usually put in this CXHY, and sometimes it even has O's in them, like that one did. You don't have to have the O's, but you can have O's in here, but it's not always necessary. And then that reacts with oxygen, making CO2 and water.
Okay.
And what these guys are doing is forming one product, and you could have it, but that's really the same as synthesis. So unfortunately, I wish I grabbed this from the book and it's really helpful, but these tend to be right here. They tend to also be synthesis too.
Okay.
But because they react with oxygen, that's the definition of combustion. When you have oxygen as a reactant, no matter what it's reacting with, it's got a special group, because think about it. What's the most common chemical all around us? Sitting around?
Oxygen.
Oxygen. And it's very important for our lives. We have to have it as living things to breathe. Or the other plants do the opposite, really, but most of the animal world has to bring in oxygen. Now we breathe and we chemically react with oxygen all the time. We are a chemical machine. You know, we're wonderful people, but our glucose in our brain, you know, when we bring in our glucose through our blood and everything, we're breathing in our oxygen, reacting with the glucose in our blood, you know, and that's the whole thing of respiration from last year. You know what I mean?
Yeah.
So I take it as a chemical reaction. And I'm even trying to do a little thing with, if I could fit this in, I definitely am going to fit this in probably after the test, just so I can get the test in. But we could like exercise in the room or go run around the hallway and come back in and blow in water and our CO2. And if we make lots of it, then we're going to make water turn into an acid. And then we can actually run an acid-base reaction with our water. I don't know. You could, actually, back in biology class, when I taught it back in 05, 06, I got this lab from Mr. Lasty, and it was called acid breath or acid water. I don't know what we called it, but what it is you could just breathe into water naturally, just kind of sitting here breathing, and you would make some CO2 and go into water. But if you're energized and you're like working out and you got a lot more, like you're really breathing a lot, you're going to make a lot more CO2. So
yeah.
Anyways, it talks about the amounts. And so we're going to talk about amounts. So when we do stoichiometry before break, we're going to run that reaction to see if we make more product.
Okay.
We're going to blow in more CO2. I don't know if that makes any sense, but
no, that makes sense.
Like you guys are the reaction, and it's chemistry in you know what I mean? And even like the whole lactic acid deal, like when you guys run really fast and your legs hurt, you know, and I don't know much about the physiology part, but I do know that you don't respirate fully, but you build up lactic acid in your muscles and your muscles get hurt.
Yeah, it's like a slow version of cellular respiration.
Exactly,
if I'm right about that. And it's cellular respiration, but it's not the quickest.
Right, right. So that's what you're leaning on. And so you're ultimately are cutting these up and at least taping together 2 or 3 of each type, and then telling me, hey, this type is synthesis, or this type is double replacement. Now my Chromebook's going to about die here in a second. So I got to plug it in. Okay. It's going to die here in the next like minute. Okay. But that's what you're doing on Thursday. So ultimately the goals going on, and how long you're going to be gone?
I get back Saturday afternoon.
Okay. So you're basically focusing on learning the types and identifying the types from all these that you're going to cut up. And then when you get to this page, you can actually keep it intact and then identify which type is which. Like this one is react.
I think you're frozen.
Sorry about that.
Oh, it's okay.
Chromebook died. But I was just letting you know that I wanted you to I don't have it connected with my document camera at the moment, but you're trying to identify which type is which. Like this first one is a compound and an element switching, and then the next one is reacting with oxygen. Then you have 2 different types, and we could even meet, you know, if you want to meet over the weekend or whatever. When we come in on Monday, and I'm even going to meet Friday, so just in case kids want to work on this together, you can practice balancing them, and you don't have to balance all these for points or anything, but the more you do, the more you get better at it. And you probably already know how to do it, especially if you've done the really hard one already. So you don't have to do much balancing because you already know how to do it. But that's one thing we're learning, and then learning the types and being able to identify which type of reaction's which. And then we're going to run through a lab on Monday. I think I'm going to have you guys start the reaction on Monday, and then we'll finish up on Tuesday. Then next Wednesday, we're going to actually have a remote day again. So I'm hoping to practice in doing some balancing along with running the lab over 2 days. And we
Okay.
might even wait and do the lab Thursday, Friday too. But I like to get 2 sets of labs in before we all come together on the 8th, because then I'm going to have the other kids do the lab while you're working on another assignment they got assigned last week. That makes any sense. So
Yeah.
next Wednesday is the SAT, and for the juniors, and I think that's you, right?
I'm a sophomore.
Sophomore. Okay, so you did physical science.
I did physical science last year, and this year I'm doing bio and chem.
Okay, didn't realize. Okay, so anyway, so if we do have any juniors, they're taking SAT if they choose to. I don't have very many juniors, but we're not going to have school in the building on that Wednesday.
Okay.
So we're going to have 2 days, and then 2 days. I like to have a quiz, like a balancing quiz that you guys can do at home, and like it'll be a quiz you're going to start on Wednesday, and then we're going to finalize it so you get it done by Friday, you know, and then we're going to physically have a test over balancing and the types by the following Friday. But I got to get the other half in. I'd like to get it done by next Friday, even with the other kids not coming in until next Monday, you know, but we want to also talk about the math, the reactions too, when we get back the next 3 weeks after that. So I think we have 2 full weeks. We have 3 full weeks together, everybody together before we have break. So that's what you're learning, is how to identify types. So on the actual page of it, you're trying to do step 4 by cutting up the strips and giving a general description of each category, and then take 2 sample equations for each category. You could either handwrite them out, or you could tape them, cut them and tape them. I think it's easier to cut these in strips, cut them up in strips, and then like rearrange them. I'll have them already, like I'll recommend this tomorrow after class. Hey, get these all cut up into strips, you know, and maybe even tell them to have like certain numbers of them, just to make it easier for the regulars, so they don't have to have all 20 strips. But you are trying to take at least 2 of each type and taping them on your description. So you're going to get your own sheet of paper. You could work on the back of this if you want, and then handwrite them out. But I think it's easier to cut them in strips. I think they're easier that way, to kind of group them together, because that's how we did it when we're in the classroom. And then you're basically, as I go through it and describe it on Thursday, is you're going to do step 4, and you're going to give a general description of each category, 2 sample equations for each category, and then you can even write them out or tape them on there. And and it's some of this stuff on here I got to change. So I know step C, don't even worry about it, because there's no item 6 worksheet. That's from my honors class from a few years ago. It's just that what happened is when we do it in the classroom, the kids are actually trying to figure out which type is which without me even giving this paper. Okay. Since you guys have this paper, you're using this as a guide. And normally when we're in here, I don't give this paper till the end of the period. Makes any sense? So it's more unknown, but you're getting a lot of guidance as you're doing it. And when we get together on Thursday. Okay? Okay. Hope that helps.
Yeah, it did. Thank you.
Okay. Well, you have a good day, and we'll be back tomorrow. I'll try to help with the balancing part. We're going to actually be on this page tomorrow. And we're going to walk through how to do level 1 and then level 2. Then on the back, I like you guys to practice several, and that's where we're going to break off, and you guys are going to try to do so many on the back. And you're going to use the program to help you balance them, you know, and it's good to also do them on paper, because you eventually are going to do them on paper. You know what I mean? So it's it's a visualization of the process you're going to do on paper. So I'm going to guide you from the program to a few on paper. Like Number 10 can be kind of more intense on this side. Number 10 is. I think 10's the most hardest on this side. But if you already know how to do number 4 on the back page, you're fine.
Okay, yeah.
You're already ahead of game. Okay? So just
Yep.
try to figure out the types and balance as many as you can. This will not be turned in for points. It's going to be your challenge paper that you're going to do step 4 on and turn that in next week. And then this paper will be turned in. So this paper will be turned in for points, and then the challenge paper doing step 4. Those are the 2 things that you're taking from here. Okay.
Yeah.
And then I'm going to have an exit ticket for both the initial notes today and balancing and the types. They're going to be different, like maybe a 5-question for each one. And they're going to be built and made here in the next couple days for you guys to work on over the weekend to have done by Monday before we go into doing the lab. Does that
All
make
right.
sense? So
Yeah.
there's going to be a 10-point homework grade on the exit ticket questions. And then there's going to be points on this paper. And there's going to be points on this paper. Okay.
Yep.
Eventually. Okay. Were you
Yep.
able to do the acid movie?
Yeah, I already got that done.
Okay. And I wanted to be sure, did I assign, I just want to be sure, did I assign anything about, I know I did it for honors, but I'm looking at your schedule chart from last week. Yeah, I think I did. I was asking kids to, acid movie. No, it was from the 18th. Hold on. Right here. Oh, I didn't do that. Well, no, here it is. It's this right here. These notes and learning percent composition. Since you're at the A group, aren't you?
Yeah.
So I don't know if you've done this yet, but I'm definitely going to be encouraging you guys to do this because when you're doing lab on the 8th and 9th, the other kids are going to be doing this. So you have like all next week. I'm going to reinforce this next week on one of the days. Hey, back on this date on February 18th, I said to you guys to learn this, right? So I'll give you another day next week to do that since you guys won't be here till the 8th. Does that make any sense?
Yeah. Yeah, that does.
And that's going to be something we're learning because we're going to be doing labs in A and B groups at times.
Yeah.
Not every lab, but this first one on copper, it is going to be done in groups. Okay?
Okay.
Okay. Well, you have a great day, and I'll see you tomorrow then.
Yep. Have a nice day.
You too. I'll see ya.
Yep. Bye.
Bye.